Terry Klinker. We're going to continue with a graphic solution of our Flair Furniture problem. So we had Flair Furniture here. We found out we were trying to maximize profit. All right. We also know that we're going to, what our decision variables are x1 is number of tables that we make. x2 is the number of chairs that we make. From the problem, we know that we make $7 profit for every table, $5 profit for every chair, so our profit is going to be 7 times the number of tables, $7 per table plus $5 per chair. We also, from the problem, had two constraints. Carpentry. It took 3 hours to build a table and 4 hours to build a chair. So 3 hours times the number of tables we build plus 4 hours times the number of chairs we build had to be less than the 2,400 hours available in that shop. In the paint department, it takes 2 hours to paint a table plus 1 hour to paint a chair, and that total of hours had to be less than the 1,000 hours available. Now we have one more constraint that is inherent to every problem. If you go back to our assumptions, all right, we have non-negativity. That means that all values for x1 and x2 must be greater than or equal to 0. This is called non-negativity. And what it means is I cannot build a negative number of chairs. I cannot build a negative number of tables or chairs. So these values must be greater than or equal to 0. For a graphic solution, what you'll do is we'll graph each of our constraints. Now this is a two-variable system. I have two variables in it. I can graph it on a two-dimensional graph. So I would have a vertical axis and a horizontal axis. The horizontal axis is going to be x1. This is going to be the number of tables. Our vertical axis is going to be x2. This is going to be the number of chairs. Where do I lose you? Some of you get confused here because you're used to it being x and y. All right? I'm trying to get you used to, in a multiple variable system, how we need to label things. So x1, horizontal axis, number of tables. x2, vertical axis, number of chairs. What we do then is we graph our constraints. Where do students struggle here? You're going to laugh at me when I say it. You're going to think it's not true, and then you're going to struggle. You have forgotten how to graph a straight line. I'm sorry, it's true. For a straight line, you need 2 points. So all I need to do is take these and find out 2 points on the line. Now the first thing we have to do is we're going to graph the constraints at the extent of the constraints. In other words, we're going to use the entire constraint. I'm going to use all 2,400 hours. So I'm going to change this. When I want to graph it, I'm going to graph it as 3x1, 3 hours for every table, plus 4 hours for every chair, is going to equal 2,400. I'm going to graph this. To put the constraint on here, I have to constrain it where I have used the entire constraint. Now, how do I find 2 points on that line? Well, the bottom line is I stick 2 values in for x1 and then calculate x2. The easiest way to do it is to do it where one of them is 0. So let's take a look at that. So I need 2 points on the line, x1, x2. If the value of x1 is 0, in other words, if I make no tables, how many chairs can I make? Well, if x1 is 0, this would be 3 times 0 plus 4x2 equals 2,400. This, of course, goes out to 0. 4x2 equals 2,400. Divide both sides by 4. x2 equals 600. If I make no tables, I can make 600 chairs. That is a point on the line. What if x2 is 0? What if I make no chairs? How many tables can I make? Well, we'll do the same thing. 3x1 plus 4 times 0 equals 2,400. This goes out to 0. So I end up with 3x1 equals 2,400. Divide both sides by 3. x1 equals 800. So if I make no chairs, there are enough labor hours to build 800 tables. I now have 2 points on the line. I can graph this line. I can come out here to x1 is 0, x2 is 600, x1 is 800, x2 is 0, and I can draw a straight line through here. Everywhere on this line, 3x1 plus 4x2 equals 2,400. Everywhere on that line, I have consumed 2,400 hours of carpentry. Now, I used 0 because it's the easiest thing to do. I could find a different point another way. I could put any number I want in for x1. I could put 100 in here. That would be 3 times 100 plus 4x2 equals 2,400. That would make this 4x2 equals 2,100. I could solve for x2 that way. I've got a point on the line. I just choose to calculate it where it's the easiest. You can put any value in for x1 since it's an equal sign here and find the value for x2. Find 2 of those, you've got your line defined. Let's do the same thing for our second constraint. Second constraint is 2x1 plus x2 is going to equal 1,000 hours. So I'm going to do the same thing again. If x1 is 0, if I don't build any tables, how many chairs can I paint? Well, 2 times 0 is 0, so that means x2 equals 1,000. I can paint 1,000 chairs if I don't build any tables. If I don't build any chairs, this becomes 0. 2x1 equals 1,000. x1 is 500. Now I've got 2 points on my line. I come out here to 0, 1,000, 500, 0, and I go through and I've got my second constraint. Now the key you have to be here is which side of this line do I want to be on? All right, I've got my line. This is my frontier. All right. On the purple line, everywhere on that line, the amount of labor that I've consumed equals 2,400 hours. On this one, everywhere on this line, I have consumed 1,000 hours. Which side of the line do I want to operate on? Well, the easiest way to do that is to stick a number, any point that is not on the line into your constraint, your original constraint, and see if it solves it. In this case, the origin is not on my carpentry line. 0, 0 is not on the carpentry line. Let's stick it in here and see if it meets the requirement. 3 times 0 plus 4 times 0 is 0. 0 is less than 2,400, so it meets the requirement. I want to be on the origin side of that line. Do the same thing here. The origin is not on the paint line. 2 times 0 plus 0 is 0. 0 is less than 1,000, so I want to be on this side of that line. What if I picked a number on the other side of the line? Let's go out here to 1,000 tables and no chairs. All right? So we'll come out here to 1,000, 0. That's on the opposite side of this line. 3 times 1,000 is 3,000, plus 4 times 0 is 3,000. 3,000 is not less than 2,400, so I don't want to be on that side of the line. All right? Same thing here. 2 times 1,000 is 2,000, plus 0 is not less than 1,000, so I've got to be on the opposite side. We can find out where we need to be. Can we graph non-negativity? And the answer is, we already have. Non-negativity means x1 has to be greater than or equal to 0. This axis is 0. So I need to be on this side of the x1 axis. x2 must be greater than or equal to 0. This is 0. I need to be on this side of the axis. So we've graphed non-negativity as well. What we end up with then is it defines where we need to be. We need to be on this side of this line, we need to be on this side of the green line, and we need to be in quadrant 1. So this is where we need to be. We have now graphed the entire problem. We'll go ahead, label some of these, talk about what it means, and get a solution in the next session.